Welcome everyone to the 9th week of lectures for the Weld 40 Introduction to Welding class. And now that we're doing some shield metal arc welding and we're starting to weld some of the electrodes, I wanted to talk to you it's really kind of a simple lecture, if you will. But for those of you that wanted to buy some welding machines, I just wanted to give you some general knowledge of it. And hopefully you're able to grasp just a couple of items. The first thing being that if you're going to go to buy a welding machine, you're going to want to know what you're going to use it for. What type of metals are you going to weld? And another important item is going to be the cost. Just how much money do you want to spend? Because these welding machines can run you from a few $100s to several thousands of dollars, depending on what you want to purchase, whether or not you want to purchase something new, or whether or not you want to look for a bargain. Myself, I use a flux cord welding machine. Both Miller and Lincoln have very good machines. Mine happens to be a Lincoln machine. It's a 140C, but it's a very portable machine for me. I can buy a welding wire for it at Home Depot and Lowe's, very accessible to purchase. And I like that versatility part of it. Plus I can just plug it into 110. However, these machines are going to run much more efficient on 220 volt. If you have 220 available, of course they make machines on 440 also. Something also to consider is, do you want it portable? I mean, do you want to be able to go out into the field in the middle of somewhere, some open field, and do some welding? If so, you're going to need to have something either gas powered or diesel powered. So that also, and by the way, if I was to buy a machine of that sort, where I was going to be doing that type of welding, I would buy either a diesel or a gas driven combustible engine machine. So just I think the whole reason why I do this lecture actually is for people to take into consideration when you're going to buy a welding machine, these two items. One is the amps, the amount of amps that you're going to run. So you wouldn't want to buy a 120 amp machine if you want to run 1/8 inch 7018 electrode. Now 7018 happens to be the electrode that we're going to be welding with on Tuesday. But I can tell you that an 1/8 inch diameter, I'm doing on my poor artistic, but this bare wire right here that's in the electrode, this is a very, very common electrode to use, 1/8 inch in diameter. You wouldn't be able to run that on that 120 amp machine. You need at least 125 amps, somewhere between 125 and 135 amps to run this electrode. So obviously that machine wouldn't fit your purpose. So you're going to want to know what you want to use that welding machine for the long term. But the other real important thing to keep in mind is, what is the duty cycle? So these are the two most important elements when you're going to buy a machine. The duty cycle has to do with the amount of minutes out of 10 with the machine's full output of amps. So I hope you can read that. Amount of minutes out of 10 with the machine's full output of amps. What that means is that depending on the cost, you can get a 150 amp machine, but only a 20% duty cycle. That means that if you're running 150 amps on that machine, they break it out into minutes of 10. So if it's at 20%, that breaks out to 2 minutes out of 10 that you can use that welding machine for at 150 amps before it starts to overheat, needs to be cooled down. Some of the old terms in the industry are buzz boxes. They used to make a buzzing sound when you reached the duty cycle. But you'll know when you reach the duty cycle of the machine because it just won't work right. It'll just kind of fuzz out and won't quite keep a steady arc. The amperage won't stay clear with it. So you know you've gone beyond the duty cycle. But if you're just going to be tacking things in your garage, you're just going to be kind of fixing things kind of here and there. Getting a machine that's only 20% duty cycle is going to suit your excuse me, I had to sneeze. It's going to fit your needs. So why would you want to buy a welding machine that is 50% or 60% duty cycle when a 20% duty cycle would fit your needs for whatever you need? The other thing to keep in mind is that it's the amount of minutes out of 10 with the machine's full output of amps. Now that's an important concept, full output of amps. So that means that if I have a 150 amp machine at 20% duty cycle, and I'm only using 120 amps of that, that duty cycle, instead of being at 20%, could go to 25%. In other words, the duty cycle will expand if you're not using the full output of the machine. Now here at Mount San Antonio College, we have 300 amp machines at 60% duty cycle. Well, obviously you're not running 300 amps. You're probably running 120, 125 amps for the most part. So that 60% duty cycle becomes about 80% duty cycle or more out of 10. And what I'm trying to suggest to you is that you can't chip the welds fast enough. You can't chip them fast enough. You can't clean them fast enough. The whole time while you're assembling plates gives that machine time to cool down. And that's how you utilize these duty cycles to your best interest. And having a machine where you can run it consistently and have the duty cycle not interfere, that's about what you want to purchase for whatever type of welding that you want to do. Now, obviously, if you want to be welding around the clock and never stop and just continue just producing weld after weld after weld after weld, you're going to have to get a high amperage welding machine with a fairly high duty cycle, somewhere in the 60% or higher range. The motor generators, those are 100% duty cycles, so you can literally run them around the clock. But wherever you purchase the welding machine at, they'll have a chart where you can look at the chart and you can see, okay, if I run 125 amps, this is going to be my duty cycle. And when you look at the 70% range, well, normally out of 10 minutes, you're usually doing something for 3 minutes. Wire brushing, chipping the weld, looking at the weld, assembling something, such and so forth. So in essence, you've just purchased yourself a 100% welding machine where you can do as much welding as you want. Now, why am I mentioning that? Because the cost goes up. The amount of money that you're spending goes up. And so that could be very, very important to you. Rather than spending $300 on a welding machine, as opposed to spending $1,200 or $2,000. And certainly when you get into the motor generators, we're talking about much more money than that. We're in the $5,000-$6,000 range. So I'll talk about that in just a moment. But these are the two most important, and really the main reason why I give this lecture is that you need to know how many amps you're going to need, and you need to know the duty cycle of the machine. In other words, if you're buying a machine with only 20% duty cycle and you're using the machine at its high output, you're only looking at 2 minutes out of 10 to be able to use that machine before you're going to have to let that machine cool down. And again, we're looking at value and cost. When we're doing welding, in essence, it's a controlled short circuit where you have an electrode, you have a base metal, and you have a machine that's moving the current. And of course, this current tries to complete itself. So as you move the electrode to the base metal and you strike the electrode, you're starting that circuit. And that circuit wants to continue. The electrons are trying to flow. And by you being close to the metal, it becomes, if you will, a closed circuit type of process where you're controlling the circuit itself. When I weld, right, I like to keep the electrode close to the material so that I am, in essence, telling the material where to go. As you back that electrode away from the material and you're way back here, the electrons, the metal doesn't know where to go, but it's still trying to complete the circuit. So if you're close enough where it can complete the circuit, it will. However, the metal doesn't know where to go. So you lose that control in the weld zone itself. So I'd like to suggest to you, keep the electrode tight to the base metal as you're doing the welding. And obviously remember, it's a consumable electrode. So as it's being consumed, you yourself are going to be moving closer and closer to the material as it goes. And those types of movements, those naturally just happen. The more and more that you do the welding, you get comfortable with that natural move. All right, so now that we know that we've got this closed circuit, there's in essence 4 different types of welding machines. I'm going to talk slightly more about the transformer, the rectifier, and the motor generator in just a moment. There's also an inverter type, and these inverters are starting to take over the industry. We have several here at Mount San Antonio College, and we have them in a bank for the welders. But these inverter type welders, they use solid state electronics, and it changes the cycle per second to several thousands of cycles per second. And you literally take what used to be in the old days like a 300 to 500 pound welding machine, and they're only about 70 pounds. So I remember being on a building, and the first time I saw my first inverter being brought onto the project. And we had these big bulky welding machines on the project. And here comes this guy trucking in, and he's got this slightly light square box with him. Powcon was the name of it. And he plugged it in. It was a 220 outlet that he plugged it into. But he used one of these inverter machines. And it was about 70 pounds. And I just couldn't believe. I had to believe just how easy that was and how well that welding was produced. So it went really well. And since then, that's been a number of years, we've purchased all these inverter machines. In fact, if you walk outside out of the roll-up doors, you'll see inverter work packs there of welding machines that several of the welders are using. So this is a very good investment. However, this is an electrical hookup. What I want to kind of talk to you about also is with these transformer, rectifier, and motor generators, yeah, they go with an electrical input. So if you've got 110, a number of these machines work just fine on 110, or 220 in your garage, or 440, you'll want to buy the appropriate welding machine for that electrical outlet. Now, in addition to that, when you go to do the field work, you can also have a gas or diesel. Now, that really frees you up. That you can put in the back of someone's truck, bring it out in the middle of nowhere, and weld up whatever you want, whether it's a fence post or a sign or whatever have you. But this versatility is very nice to have. And in addition to that, if you're going to get a gas or diesel machine, make sure that the machine has an electrical outlet or a receptacle, if you will, so that you can plug in a grinder, you can work on a drill. I know in the old days, these outlets used to be direct current only, not AC current. And that presented a problem because a lot of the plug-in items, they were only AC, and they would burn up if you plugged them into a DC outlet. But things have improved in the industry. Just make sure when you go to buy something, whether it's gas or diesel driven, that it does have an outlet and that it is AC power. And then you'll be able to use whatever tools you may have. Okay, I think I've talked about everything here. Two important concepts, and I know you need to hear this a few times for it to be fair, because a lot of you are hearing this for the first time. But, I mean, unless it's a flux cord or MIG machine, every welding machine has constant current. In other words, when you dial in the amperage stays consistent with the machine. We call them constant current machines. There's also machines called constant voltage. And these constant voltage machine are your MIG and your flux cord arc welding. Now that will be in my next lecture to talk to you about. But you can buy machines that have constant current, and then they just have a switch that you just switch over onto constant voltage, and then you can hook up your MIG machine or you can hook up your flux cord arc welding machine. All I want to do is establish to you this language of hearing this language that you cannot run gas metal arc welding or MIG, and you cannot run flux cord arc welding unless you have constant voltage with that machine. You have to have that capability of the machine in order to use these two processes. Other than that, you know, everything else that's purchased all have constant current. I mean, you can imagine if you were welding with an electrode and the amperage just did this the whole time where you were welding. It just fluctuated. You'd be all over the place. So these are constant current machines, and the amperage stays consistent. It's where you go to these semi-automatic wires where you're activating the wire with a trigger on the nozzle. And so the wire gets fed. Those semi-automatic wires require constant voltage. And again, you can either have a converter on the machine or you can buy a converter on a constant current machine and have one installed into the machine. Or you can have that switch on the machine that moves it from constant current over to constant voltage so that you can run these semi-automatic wires. Or, of course, you can just buy a flux cord arc welding machine. That's all it does is flux cord arc welding machine, and that will be a constant voltage machine that you're going to be working with. So I wanted to take, not just talk about the amps and the duty cycle, although those are the two most important items. I also wanted to take just a moment to talk about what are the big three, and they are transformer, rectifier, and the motor generator type. The transformer welding machines, they're the cheapest. These are the cheapest to buy, at least expensive. They are alternating current only. So this is to me, this is a minus, if you will. Where you can only run alternating current with the transformers. You know, most of the time out in the industry, most people are using direct current. So not having that ability is not something that I would invest in. Yeah, I'm just telling you my personal. But if you're going to use this in your garage and you're just going to be tacking things every once in a while, this might be a very viable alternative for you. And you can get a fairly cheap machine this way. So this might be a way for you to go. The cost obviously is low. The duty cycle is low. You know, so you're looking at 10, 15%. You might get lucky to get 20%, but it's a fairly low duty cycle. So I'm talking about minutes out of 10 with the machine's full output of amps. More than likely, you're going to be using smaller electrodes. So probably 1/16 electrode, something like that with these transformer welding machines. You really can't weld any large electrodes with it. These transformers and rectifiers, a lot of these have movable coils. And with these movable coils, I know a lot of you have used these at our welding shop here the last couple of weeks. So when you're cranking on that wheel that's in front of the machine and you're watching the pointer move on the machine and you're looking at the numbers, really what you're doing is you're moving a primary winding. There's a primary winding in the machine, and you're either moving it closer or further away from the secondary wire. This is inside of an iron core, and the closer that you move this primary windings to the secondary windings, your amperage goes up. The further you move it away, the amperage goes down. So I know not all of you are using these movable coils, but those that were cranking on the wheel, that is in essence what was going on inside the machine with these movable coils and adjusting the amperage that way. Now once you move away from the alternating current only machines, now you move into the rectifier machines, and those are the ones that we use at the college. And those machines have alternating current and direct current, which means they take the alternating current and they allow the electrons to flow only in one direction instead of this fluctuating current. Typically, your alternating current is 60 cycles per second here in the United States. And of course, half the time you're positive and half the time it's negative. So it's 50-50 on that plus minus. But once you move it over to the direct currents, now the electrons are moving in one direction. When you move into these rectifiers that also have these movable coil type setups, not all of them, but some of the machines have that type of setup, the duty cycles increase. So you get much higher duty cycles and the amperages increase. So obviously the cost is going to go up. You can TIG and you can MIG with these machines if the rectifier has constant voltage. Again, you got to have that constant voltage connector with it. But my point that I wanted to make here is that a lot of people buy these arc welding machines for shear metal arc welding, and then they want to use other types of processes with it. So you can certainly TIG weld. You can buy a TIG setup and hook up to the leads. This only requires constant current, so you would be able to TIG weld with it. You may have to buy a pedal. You might do a scratch start with the TIG welding, but they make portable units to be able to connect to these types of welding machines. And then, of course, they sell them all in one, where it's all part of the welding machine itself. So you can kind of piecemeal it, or you can buy it all inclusive. But you're looking at 400 amps. That's quite a bit of amps for anyone that's going to be doing shear metal arc welding for sure. And you're in the 60% duty cycle. So you're looking at 6 minutes out of 10 using the 400 amps. Well, I mean, let's say I'm using the 1/8 inch 7018 electrode. So I'm only using 125 amps. And that brings this duty cycle into the 80s at least, 85% duty cycle. So I'm looking at 8.5 minutes out of 10. I will never reach the duty cycle and where the machine stops working correctly. So I know I've said that a few times, but it's an important concept if you're going to go buy a machine. And whether or not, you got to open up the wallet, you got to knock the cobwebs out. Am I going to spend that extra $100 or an extra $500 for that machine? Know what you're purchasing, and are you going to get your value for what you want to use it for? With the motor generators, well, those have an armature rotating in an electric field gathered by a commutator. The current is picked up by brushes. I remember switching the brushes out in the old Lincoln SA200 machines, but that's where the amperage is picked up from. These motor generators are either electric or they're gas or diesel driven. And that's going to be your choice. What kind of fuel do you want for the machine? Sometimes noise is a concern. So people only want to have an electric hookup. But yet, you know, I can set the machine outside and run 100 feet of cable in, and the noise would be outside. Obviously, I don't want to bring a combustion engine inside anyways, but you know, sometimes that might, I like to offset that noise factor with that being outside, with the fact that I can take this anywhere that I want to go, out into an open field and perform whatever type of welding that needs to be done. Okay, so when you move into the motor generators, you're looking at 100% duty cycle, 600 to 900 amps. All right, so now we're way up on the scale. You can fairly much weld whatever you want. You can certainly air arc. When you get into the air arcing process, where you're air arcing a weld with the air or carbon arc process, you need these extra amps for that process. So that's where these motor generators would really come into play. And of course, the cost is up there, folks. You're looking at $5,000-$6,000 if you want to get a brand new and really nice machine. Now, all that being said, I want to tell you, and I'll talk more about this with the flux cord when I do that lecture. But I just have a flux cord machine, and I can plug it into 110. I can buy the wire at Lowe's and Home Depot, and I've done a whole lot of welding with it. I like that flexibility of that machine, being able to tote it around and plug it into 110 wherever I'm going. So again, it's each individual's preference. What is it being used for? You know, do you want it for a lot of years? Miller puts out an excellent machine. So does Lincoln. When I go to buy something, I like something, you know, that's been proven. Although a lot of these other machines have been doing quite well also. It's just I would do the research before I actually spend my money on the machine itself. So conventional theory is negative to positive. That's how the electrons flow. Keep in mind that 1/3 of your heat is on the negative terminal. 2/3 of your heat is on the positive terminal. So I want to take just a moment and go back. We're going to talk about polarities for just a split second. And take a look at this diagram right here, right here. So when I'm looking at a machine and it says AC, DC plus, and DC minus, there'll be a switch right here. So I can take this switch and I can move it on to AC, DC plus, or DC minus. You know, what polarity do I want? Well, in this case, on this one that's drawn, this is DC plus, because we always go by the electrode. So the electrode that's in the welder's hand, in this case it's positive, so it would be DC plus, which means 70% of the heat is with the electrode, which is why I end up getting the best penetration with the DC plus current. If I was to switch the leads at the machine, it's very, very easy to do. At the machine, right, you're going to have a positive terminal and a negative terminal, and you're going to have leads coming off. So I can just switch these very easily. So if I switch these leads at the machine and make it DC minus, all right, now the electrode is minus and the workpiece is positive, which means that I've got 30% with the electrode, which means that I end up with shallower penetration. I don't get as much penetration into the metal itself. And of course, that's when we use the DC minus polarity, is when we're dealing with thin metals. You know, I mean, there's other ways of working with thin metals. You can certainly MIG weld them. You can use the light gauge flux core wires, the smaller wires on flux cores to weld the thinner metals. But if you were to shield metal arc a thin metal, you would want to use the DC minus polarity. Now, that being said, let me tell you, at least state it, that in my coming up on 40 years of being in the welding industry, folks, it's been like over 99% of the time of my welding has been on DC plus polarity, because I'm trying to get the best penetration I can as I'm doing the welding. So this is a polarity that's used quite a bit in the welding industry. Now, I don't want to downplay that, there's other places for these other polarities. It's just that the alternating current isn't quite as popular as you might think with someone, although if someone's in a garage, if you will, and they just want to tack things here and there, they would probably go with alternating current. Or if you're welding on thin metals, using the DC minus current. I just wanted to state to you that usually most people out in the industry, fabrication shops, they're working with DC plus current when they're doing the work. And I think for the most part, that could very well close this. I did buy one Miller machine. I had a Miller machine that had an arc booster on it. It was kind of nice. It was just a switch on the machine and I could call for it. And what it would do is it would throw a few more amps when I go to start, when I go to strike it. And I thought it was useful, rather than getting the possibility of a cold strike and the electrodes sticking to the pipe or to the metal. You get those extra couple of amps, and that's also something to get with the machine. The last thing that I wanted to say to you is I have a flux core arc welder. It's a 140C. It's a portable one, and I bought it for $750, and I got it quite a few years ago, a number of years ago. So I've had it for a whole lot of years, and it's more than paid for itself with just side work and things here and there. But what I wanted to say to you is right after I bought it, I saw it in a penny saver. So I know we don't have penny savers as much anymore, but I found it in a penny saver, someone that had bought one and just wanted to get rid of it. And it came with a cart for $350. So I looked at it. It was the exact same machine that I had, and it had a cart, and it was $350. So I'm going to just leave that with you, that if you're not in a hurry to get something, and speed or quickness isn't part of the process, give it some time. Watch the papers, Craigslist, any of the ones that you want to name. But look out in the industry. There's companies that sell old welding machines. That might be an option for you. Maybe go and visit one of those shops and see if any of the welding machines are in decent shape that you might want to invest in. Maybe something that's been refurbished. But also, I like the idea of someone that got a welding machine and they for whatever reason they want to get rid of it. Some people are moving. They didn't use it much, type thing. And you can really get a bargain that way also. So I think that wraps up my talk on the machines. Always keep in mind when you're going to buy a welding machine is amperage. How many amps does the machine put out? And how many amps are you going to need when you're going to be doing your welding? And also the duty cycle. That 20% means 2 minutes out of 10. That 40% means 4 minutes out of 10. And we're looking at the machine's full output of amps. So be sure you're buying a machine that has enough amps and the duty cycle that will balance the amount of minutes out of 10 that you actually want to require the machine to be used for. All right, thanks everyone.